like things, like you can't get a learning disability or like a mental illness from a vaccine. Like where is the connection? Like you're not changing anything in your brain, like chemistry. You're not, it's just it's working with your body, like your overall like immune system. It nothing to do with your nervous system or
but
your
that because you know how it works. But my mom has sent me and they explain it in a way people will believe it.
Right. Ay, no, pues, ¿cuál es?
Like, who has the mind to put up these videos? I mean,
yeah, honestly.
Right. I know.
Conspiracy theories.
I don't know. But
well, it's always the same. Everybody's gonna, and everybody has the right to do whatever they like.
Right.
Okay, so I'm seeing you're subtracting here. So are you subtracting, okay, each one of these? Okay, and you do the same thing for each column right here, the asleep and awake. You do your sum of x, the n, which is 8 because there's 8 data points. And then we have the x1 or x2, like this is the mean, which is just basically adding and dividing by how many numbers there are. That's how you get that. And then the D, the first D is just subtracting these ones. What about the D2? It's just squaring the D column.
That's exactly right.
Before you continue,
okay, good.
Yes.
Okay. I know it's late. I'm sorry I couldn't get into the last week class, but
that's okay.
I wonder if in the test, the last exam we had,
yes,
I had different results. Even I had them right. I have them because I figured it out. Well, it has to be this one. But since the sum of x, I had them different, and I don't know if anybody else had them that way. I'm so worried. No. If I'm the only one, then I didn't answer.
I didn't even do it. Like, what do you mean for which, from the which worksheet or which?
The last test where
one problem.
Yeah. That was my bad. Irene, that was my bad. I had it wrong.
Yeah, that one. Okay.
So you were right. Yes, you got some validation there. Yes, you guys were right. I transposed a number incorrect in my notes and in my calculations. The very last number I had 17, but on the test it was 11. So you guys added up to 126 and I added up to 132. So so I apologize for that. If you went back, you should have noticed on the test, I added back points to everybody. So don't stress about that. Okay.
Okay.
That was my bad. Yes.
Okay.
That was my bad.
Just well, I think you did mention maybe last week you mentioned like briefly, I guess, like, or you didn't mention paired like sample tests last week, did you? Or I mean, I know in last class maybe yesterday you did, but last class I mean like last week, like on Tuesday, did you mention that?
I believe all we did last week was I just talked about that there are 2 different ways to come up with, let's see, this isn't what I wanted, that there are 2 different ways to come up with a 2 sample t-test. And I talked a little bit about this. I'm just going to show you right here, like different ways that we can come up with the types of pairs. And then I think I briefly showed this, not too much. And then I talked a little bit about independent samples t-test. So that was all that I did last week, Natalia. So yesterday was definitely more going into those types of, or the formulas.
Did you put up all these?
Thank you.
So I need to put up this kind of updated one that I have with the new formula, and I will do that. I haven't done that, so I need to swap it out. You won't notice much of a difference, but you'll see that it is technically different. This one that I want to put up has the formula for the independent samples. And it has this example or, you know, a thing here that you could work through or that I worked
Yeah,
through
So
yesterday.
we print it. So I like to print them so I can, so it helps me. And
Yeah.
it's gonna be chapter what, 11?
No, it's still on the one that we had. It's still this one that's just called like t-tests.
Yes, okay.
And this is chapter 10 still.
Okay.
Okay. So it's going
So
to look,
okay. That's
it'll
okay.
look the same, but I'm just going to say like, maybe I'll say updated. Okay.
Do you feel bad?
Okay. So one thing I just want to, Natalia said that our N is 8 because of the 8 data points. And I'm just kind of hanging on that. I don't want to be nitpicky, but we technically have 16 data points. Our N is 8 because we have 8 participants. Okay.
Oh, 8 participants, sorry.
Yeah, and no, you're good. I just wanted to point that
Clarify.
out.
Yeah.
But the reason why we're staying with 8 is there are 8 participants, and this is a paired sample, so that yes, we do have 16 data points, but this is the same person going through one level of the study and then the second level of the study. Okay, so this is what we would call a repeated measures, just to be technical. Okay, this participant did a test after he got to sleep, and then he did the test after he had to stay awake. Okay. So this is a paired sample, and since it's a paired sample, we have to calculate D. Okay, and D, if you remember, stands for the difference score, the difference score. So what we did was we took the difference between his 2 data points. So 4 minus 2 equals 2. 3 minus 2 equals 1. 5 minus 4 equals 1. 3 minus 0 equals 3. 2 minus 4, negative 2, we got a negative right here. I'm sorry, 4 minus 3. Oh, Cassandra, did you catch that? No. I'm glad I read through it. I was wondering if you were just sitting there watching and waiting for me to make that mistake. Okay, 4 minus 3 is 1, 3 minus 1 is 2, and then 6 minus 4 is 2. Okay, that sounds correct. Now, I always told you guys that negatives, for the most part, don't matter in statistics, or they don't have, maybe I shouldn't say they don't matter, but they don't have the same, I don't know, influence or whatever that they do like in algebra as they do here. We get to ignore them a lot. Not in this instance. This guy's going to be very important right here. We can't just ignore him right now. Okay. So what that means is I need you guys to play with your calculator. Don't ignore this -2 here. Okay. So what I'm going to do is I'm going to start adding these up because we need to get the sum of D. Okay. So we have 2 plus 1 plus 1 plus 3 plus, right? Let's see, I'm going to do plus, oh, that's not even, oh gosh, where is it doing it? It's just doing it in the middle of my page. All right, here we go. One more time. All right, 2 plus 1 plus 1 plus 3 plus negative, oh no, let's see, hold on. See, this is what I want y'all to do, okay? Let me see, let me try it again. 2 plus 1 plus 1 plus 3. I'm gonna skip it right now. Plus 1 plus 2 plus 2, and then plus -2. Does it work that way? Let me see. I want you guys to see how to, I mean, obviously you could do it in your head. Do what?
If you just subtract it.
Yeah, for sure. I was just going to say, I mean, obviously you could do this in your head, or you could just, at the end subtract it off. I just wanted, in case anyone's playing with their phone or they're, trying to do it on this, obviously there's a way to do it. I'm going to do it like this and add it at the end, equals, but I don't think does it come out to 8? Or did I skip a 2? 1, 2, 3, 4, 10, 11, and 15 minus 2, right? So it should come out to 13. Correct?
I got 10.
Oh, you did?
Yeah.
Did I add up crazy? So see, I'm telling you guys, I'm horrible at math. Okay, 2 plus 1 plus 1 plus 3 plus 1 plus 2 plus 2, right, should equal 12. Yes, right. And then you would put in there that -2, so it would bring it to 10. Yeah, okay. Yeah, I don't know. I'm going to stop messing with my calculator, but you guys figure it out on your calculator if you want to, okay? How to punch that in there to make sure. Obviously, I agree with Cassandra. I mean, you could sit here and just add up the positives and then subtract the negatives. If you have all negative, it's easy. If you have all positive, it's easy. Just really hold on and watch yourself and make sure you pay attention to the few, if you just have a few negatives in there, okay? So, all right, there we go. So finally, our sum of D is 10. And so now we just square them, right? And here we get to go back to not worrying about the negative, and because it'll go away, right? So now we have 4. Let me get over here. 4 plus 1 plus 1 plus 9 plus 4 plus 1 plus 4 and 4. And I get 28. Yeah? Okay, good.
I'm sorry, why do you not have to worry about the negatives?
Well, just when we're squaring it, remember, because a negative times a negative will turn positive.
Oh yeah, true, that's true.
Yeah,
That's true.
so that's why I say you don't have to worry about it in the
Okay.
squares. Yeah.
Okay.
Okay, so I went ahead and when I did this work right here, this was just saving us a little bit of work. I mean, we have to do it no matter what, because when we eventually do the t-test, we need the mean for each of these, kind of quote unquote groups, right? We're going to need the mean score that people tested when they got to sleep. And then we need the mean score for people when they tested when they had to stay awake. Okay, so that's why I went ahead and did those right there while we were talking about vaccines and so on. The D, right, you have to calculate D, okay? And we need the sum of D, and then you have to calculate D squared because we're going to need the sum of D squared, okay?
Where do you get x1 equals 3.75 and the x2 equals 2.5? Where do you get those?
It's the mean, Irene, and what I did was I took 30 divided by 8 gave us 3.75. And then the sum of this column over here, oops, what was here? Was it 4? The sum of this column was 20 divided by the 8 is 2.5. So I was getting the average for each group. Okay, good question.
Is it always the case to have D, like to do like 2 D columns as well, like for every like paired sample t-test?
That's right, for the paired, yes. That's
so
yes.
that you always have to do that for every problem. That's one of the processes.
That's like your first, yeah, your first step or your second step. Okay.
Okay.
In a paired.
Yeah.
Okay. In a paired, you have to calculate D. Okay.
Okay.
Yeah, because right, we're trying to get the difference between the two scores. Right. That's That's kind of the point of the study, right? Is to see
Mhm.
how the people either got better, or did they do worse, or did they do this, or did they do that, right? So that's kind of the point of it. Yeah.
Okay.
Okay.
And
Oh, go ahead.
one last thing.
you're
So this is for paired, but there's also another type of. You said that there was like an independent
That's right.
sample t-test. Did you guys do an example of that yesterday, or like just to?
Yeah, we went over it and we did an example, and we're going to do an example today. I haven't done
Okay.
it yet. Okay.
Okay, that's fine.
Yeah, so we're going to go over that one as well. All right.
Okay.
So I'm going to start here, the step 1 for this problem. Okay, so step 1 is the hypotheses, right? So we're going to try and write out our null hypothesis. I'm just going to put the HO because I don't want to worry about subscripts and things like that. So the null hypothesis states that there will be no difference between the two means, right? There's not going to be a difference. Now, to put it just a little bit differently, or to expand on that, we'll just say there's not going to be a difference in memory for when people get to sleep compared to when they have to stay awake. Or let's see, maybe I could say it differently. There will be no difference in memory score between the sleep group or asleep. What am I trying to think of? I guess, I mean, a sleep treatment doesn't really make sense, but
Mention like the scores and stuff like that in our hypothesis.
wait, do what? I'm sorry.
We have to mention like the scores.
Like these scores?
I'm wondering if mine are wrong because I just put.
What did you put?
I put for the null, sleep has no effect on memory, and then for the other one, lack of sleep affects memory, but I don't know if it's too like.
Nice. No, I like it. Is this Cassandra?
Yes.
Sorry, I minimized you guys, so I can't. Cassandra, I like it. I'll be honest with you, and to me, it clearly shows that you know what you're comparing, and it shows you know what you're talking about. When and if you go up to UTEP and you have to take it, different stats classes or general experimental, they might have you get a little bit more detailed than that. They might want to know how memory, what do you mean by memory, right? And then that's where I put the memory score. They might even make you write in mean, they might even make you say, well, what are you comparing? The mean memory score. They might want you to clarify which groups, and even though what you're telling me, I fully understand, right? They just might have you be a little bit more detailed. And so just so that you can show them, what are the two groups that you're comparing. Does that make sense?
Yes.
Okay. But and you'll never know, or we won't know until we get there, right? What they're going to have you do and what they'll require you to do. So you just, I guess, whatever that professor is asking of you, just do it that makes them happy, right?
Yes.
But yeah, but I do like your statement for sure. I'm just going to put in mean memory score and leave it at that right now, just to save time. So there will be a difference in mean memory score. Okay, step 2, right? So we have to find the critical values. And we do that exactly the same as we've been doing. We have 8 participants, so the critical value would be 7. I'm just going to pull this up real quick so we can look. 7, two-tailed right here, 2.365. Okay, degrees of freedom of 7, 2.365. So let's see. Plus or minus 2.365. Okay. And then now, yay, we get to do all the I'm going to scoot this guy way down. We get to do all
I'm
this.
sorry.
ahead.
So the scores, the mean scores are the ones that are the 3.75 and 2.5, or which are the mean scores?
Yeah, yeah, exactly.
Okay.
That's
Okay.
exactly it. We're just saying that the mean, these are their memory scores. They were given a list of words. Yeah.
Yeah.
And so this was like his score when he got to sleep. He remembered 4 words, and when he was forced to stay awake, he only remembered 2. Okay.
Yeah, no. I was
Oh.
just wanting to clarify that because you said like difference in mean memory score, so I wasn't sure which one it was, but now I know.
Now you know. Okay, perfect. All right, so let's see. Is this gonna let me type down here? Oh. Maybe not. So that's okay. I'll just start typing right here. So then step 3, right, are our calculations. So let's get started. Calculations. Okay. All right. Let me see if I can pull this up. Just, oops, not that. So you guys can see the formula. It's the same, not that one, but it looks like that one. It's the same formula more or less that we're interested in or that we've been working on. It's just now instead of X, we have D. Okay, so D is the new X in a paired sample t-test. Okay, so let me get my pencil up here. All right. So our estimated is equal to, we need the sum of our D squared, which we calculated right over here as 28, minus the sum of D, which is 10. This is why it's really important to get your sum of D correctly, right? I was making all those mistakes and trying to figure out how to do that -2 in there. So that's why I was kind of getting hung up or kind of being OCD about that. I just want you guys to make sure that you have to add up this column correctly, right? If you don't add it up correctly, it's going to throw all of your formula off and eventually your T, okay?
So in that test, what it was wrong since the beginning was that number.
Yeah, exactly. Right? Yeah. Okay.
Because I went crazy. I did it so many times. I'm like, where did she get this number?
I'm sorry. I know. Okay. I'm sorry. I'm sorry. I know. So bad of me. So bad of me. I went ahead, squared this. That was 100. I divided by 8 and I got 12.5. Now 28 minus 12.5, I get 15.5 divided by 7. Oops, let me scroll a little bit. I ran out of room here. Remember, we're always remembering to bring the house down. I get 2.21. Let me do this one over here. 2.21 square root. And so for our estimated, I get 1.4, I'll go round that up to 1.49. Let me see. I want to see. Yes. I'm like, I wanted to check Cassandra's face to see if I got the nod. All right. I got the nod. So yay. If you're working along with me, Cassandra said she had already done this. So that's awesome. That's 2 of us. Irene, I want to make sure and see if you got the same thing. Yeah. Okay. Awesome. I got the head nod over there too. Okay. So now we need to do the sum, the standard error of a difference. Okay, it's just called a little bit different because we're doing something else. We're not talking about standard error here. Well, we are, but it's standard error of a difference because we're looking at the difference scores, right? But for us, that doesn't really mean anything. We still do the same thing that we're used to. We take our estimated and we divide it by the square root of our n. Okay. So I get 1.49 divided by 2.83. And so 1.49 divided by 2.83, and we get 0.53. Yeah, okay, we got another head nod. Nice. I like it when I'm on track and I'm doing stuff right. Nothing worse than not doing it right.
Just go to Cassandra for approval. She's like the head nod means you're on the right track.
I'm on the right track. I know. It's nice. I wish, Cassandra, can you just follow me around everywhere and just do that? I can just turn around and you're either nodding or shaking your head that I know whether I'm doing good or not. All right, so we need now our t, which is always in some form or fashion, one mean minus the other mean, right? In our single sample, we were doing our sample mean minus the population mean. Now that we're in 2 sample, we're doing the mean of this time 1 and the mean of time 2, if you want to think of it that way, or group 1 compared to group 2. Okay, so 2.5, I think I remember. And then all of that over this 0.53. Sorry, my handwriting is really bad. Okay, so let's see, we have 3.75 minus 2.5, and I get 1.25. Ooh, and cut that in half. We're pretty much gonna get a 3 or something, I think. Let's see. 1.25 divided by 0.5. Oh, what happened? 1.25 divided by 0.53. 2.35 or 36. Does that make sense? Yeah. Okay. I overestimated. It wasn't exactly right. 2.36. Oh gosh. What was our? What do we do? That's so close. It's so close, but it's not going to make it, right? It is just not going to make it, guys. Is that what you did, Cassandra? Or were you wondering?
No, I'm like, okay, the critical value, it's 2.365, right?
Yeah.
And then this is 2.36.
Yeah.
And
it's only 2.36 because we rounded up, right? It would have been 2.358. So I say that's a no-go. It's close, but no cigar, right?
Yeah.
So step 4, make a decision time. I would say we have to accept the null hypothesis or fail to reject. And the reason why is, if we want to draw it out here, I'll try and draw I say as best as I can as I draw that really crookedly. But let's see. So our critical value was 2.365, right? And the number we got was 2.358. I mean, it's like, it's so darn close, but it's not the same. It's not equal to, and it's certainly not on the other side of that critical value. So we have to reject it. Okay. So we, or I'm sorry.
Wait, hold on. So it's accepting or rejecting, which, because
Yeah, I made a mistake. It's accept it or fail to reject.
fail to reject because
Yeah,
it doesn't go beyond
That's right.
Okay.
Yeah, it did not go beyond that that critical value, or that it's
I
didn't make
have
it
a
in there.
question.
Uh-huh.
I know, I'm sorry, I didn't get in the other class, so I
That's
watched
okay.
the video, but I'm lost. Where did you get a critical value?
Okay, so the critical value comes from, you need a couple things to get critical value. You need your degrees of freedom, which
Degrees
is
of
n
freedom.
minus 1. And so that came to 7, right? Because we had 8 people.
Mm-hmm.
Okay. And
Yes.
then you have to use the back of the book. You
Yeah,
have
that
to
chart.
use, yeah, that T table. I just look here because it gives me a little picture of it, but
Yeah.
you can find the whole one in the back of your book. Okay.
Yeah, I printed.
Okay. And then we always go, unless you are told otherwise, you always do a two-tailed 0.05. The two-tailed 0.05. Okay. And so we go down and we find 7, and there it is, 2.365.
Okay, thank you.
You see it? I mean,
Yes.
really, Irene, you could always like just highlight this whole column,
Yeah.
because that's pretty much where you're always going to be.
Okay.
Okay.
I will.
Yeah, unless they tell you otherwise, unless they, and I won't, but if another professor says do a one-tailed at 0.05, then you go up here in the one-tailed and the 0.05. It just determines which column you're in. Okay, but you always use degrees of freedom, and that's how you find that. Okay. Good question.
Okay, so it's gonna be, wait. So it's gonna, I have my chart in here.
Oh yeah.
So it's gonna
okay.
be in that two-tail.
Yeah. Oops, I didn't mean to do that. Two-tailed. Do you see here? The two-tail.
Yeah.
And then the 0.05.
I'm lost.
That's okay. Are you in the book?
I have it right here, but it says in this one, two-tail. In the second one, one-tail. So is this one?
Okay, so yeah, just find whichever one that, yeah, they might be flip-flopped. Find the two-tailed 0.05 or match it up. Look, can you match it up? The one that, if the degrees of freedom of 1, it should have the 12.706 there. It's that column.
Which number?
Look, if you have degrees of freedom of 1, it should be the column that has the 12.706 starting it off.
You know what? I just print this one from whatever you gave us, and it's different because in the one, it has 12.71. In this one, I got this one from the.
Oh.
I got this one. I print this one from the one you gave us on the PowerPoint.
Oh, let's look it up. Okay. Or, oh, on the PowerPoint or up here in the course? The course
that one
documents.
In the course. Yeah.
This
See?
one. Oh, yeah, it does. Oh, yeah. Okay. Yeah. Sorry.
So,
all right. So there you go. So here is your two-tailed, the 0.05. And so, yes, you're in this column. Yeah, they just, that's weird. I don't know why they did that, but they rounded up right there, right?
So in the number 7 is the same number. Okay.
Yeah, okay, and yeah,
Okay.
you see that, right? So
Yeah.
7 across is still 2.365.
Yeah. Thanks, God. It's
Okay,
the same
good,
number.
good. Yeah.
I have a
All of these
question.
tables, you know, can be printed differently, which to me, I just wish people in statistics would stick to the same thing. Because sometimes you can look these up and, oh, they're so confusing and they're so hard to read. But yeah, that's it. So, okay, there you go. You highlighted that. And so we had to fail to reject, or we had to accept the null hypothesis because, sorry, but 2.358 does not exceed 2.365. It's very close, but it's doesn't match, right? It doesn't equal or exceed it. So we have to accept it. And so ultimately, right, if we were going to write a conclusion here, right, so we have to accept the null hypothesis. We can always say something like, there is no evidence, to support that staying awake or sleeping affects memory, I guess. I don't know. I said it kind of differently. I'm sure Cassandra has a more eloquent way. How did you say it?
I didn't write a conclusion.
Oh, okay.
I just used what I had wrote for like the H1 and the HO.
Yeah. Yeah. And honestly, I was thinking when you said your hypotheses, those are excellent ways that you could use those to word your conclusion, right? And so I want to say what was your null hypothesis again?
It was that sleep has no effect on memory.